when you think about those two sides, which is the data capture and the production, there's actually also a piece in the middle, which is how do I design N of one designs to produce by the millions in real time without any human intervention?
Welcome to the 5-Year Frontier podcast, a preview of the future through the eyes of the innovators shaping our world. Through short, insight-packed discussions, I seek to bring you a glimpse of what a key industry could look like 5 years out. I'm your host, Daniel Darling, a venture capitalist at Focal, where I spend my days with founders at the very start of their journey to transform an industry. The best have a distinct vision of what's to come, a guiding North Star they're building towards, and that's what I'm here to share with you. Today's episode is about the future of 3D printing. In it, we cover mass customization at scale, computer-led design, creating the unmakeable, printing body parts and food, and the future of product design and production. Our guide will be Philip DeSimone, co-founder of Carbon, headquartered in California and serving customers in 17 countries from Adidas to Ford. Carbon is 3D printing technology company helping businesses develop better products and bring them to market in less time. Carbon is a vertically integrated organization developing 3D printing hardware, advanced material science inputs, and designing the software to make it all work seamlessly. With over 300 patents filed, Carbon has raised $680 million from the likes of Sequoia, Temasek, Adidas, BMW, and Google. Coming up on 12 years since co-founding Carbon, Phil leads Carbon's go-to-market strategy and manages their most strategic partnerships and customers. Phil, thanks for coming on and talking with me today.
No problem. Thanks for hosting us.
3D printing was invented in the late 80s, and it's one of those old infancy technologies that no one's been able to crack yet at meaningful scale. So can you tell me what's coming together to make the promise of 3D printing a reality?
One of the major things that's happened since we were founded, not just pioneered by us, but also from other people in the industry, but really trying to take an approach where we focused on both hardware, software, and materials in unison to really drive on the promise of additive. And the promise was always there. These always had the capability of being digital portals for physical goods. The problem is the technology was too slow, the materials were not good enough, and the understanding of how to take advantage of it, which is a little bit more of a educational problem, I would say, was not fully understood. And that was when things really for us, really started kicked off and going, which is we knew that if we could come up with a printer that was printing things in minutes, not hours, it was using materials that were robust, that would be good enough for a production application, as well as really helping on an education perspective of how to take advantage of the equipment effectively, that you would get to a spot where you could really live up to the promise of what additive held for the market.
Looking at this moment where Carbon comes out and is able to do things at mass scale that wasn't done before, what were some of the technical innovations or what were some of the things you had to do differently to the rest of your peers in the industry?
So the main thing we originally started to focus on was around the print time. Again, as I suggested in the earlier commentary and earlier question, it was not uncommon for parts to take 10, 14, 15 hours to produce a singular part. And I think this was the misunderstood aspect of 3D printing. A lot of people talk about 3D printing. Not many people have actually had access to a 3D printer and seen what it's like. But we knew that if you couldn't print things at a quick enough turnaround time and a quick enough pace, that it would not matter. The economics would simply never work out. We developed a technology that we call digital light synthesis, which took a material science approach to printing fast instead of a mechanical approach. Historically, 3D printers were all mechanical production of a 3D object. So if you think about it, even down to the claim language in the IP, it's the layer by layer production of a three-dimensional object. We knew that we can get around the layer by layer aspect and into a place where it's more of a continuous printing concept. Think about the Terminator scene where he's coming out of the metal pool in real time. Then we knew that we could make something significant. And so in 2015, we launched that concept on the stage of TED. We printed an object on stage that took 5 minutes, the entire length of the TED Talk, which that object done on any other printer would have taken 10 plus hours at the time to be able to do. And we knew that we could crack that code into a world where you can get things to print much, much faster. And we talk about some of the work that we've done and proven that. We've worked with companies like Adidas to launch shoes at scale, which I think you think about commodities of all commodities, nobody ever believed you would be able to walk into the store to buy a pair of shoes that were printed off the shelf at scale. And, we essentially are in a place now where we're producing pairs of shoes in 20-ish minutes a pair, which essentially means that you have about 50 machines to make about 1 million pair a year.
Wow.
Which truly gets to a large scale speed change. So number one was speed. The second piece of it was the materials. If you printed faster, but you couldn't make a material that was good enough to be a production material, it wouldn't matter. You essentially just made a faster prototyping tool. So unlike a lot of the other 3D printing companies out in the space, our engineering team is about a third hardware, software, materials PhDs. We started focus on developing our own materials. And so we pioneered in the second major innovation is we pioneered a technology that we call dual cure. And we sort of flipped it on its head, which is historically 3D printers would use light to not just make the shape of the object, but also dictate its ultimate mechanical properties. So they were using light to do both of those things. We sort of flipped that on the head, which is, well, what if we use light to set shape, but we use chemistries, reactive chemistries to set the ultimate mechanical properties? So decouple the two. All we're doing is using the light to set a scaffold, and we're using reactive chemistries similar to what you would see in a 2-part epoxy system adhesive that you would buy at Home Depot, or a polyurethane reaction injection molding system that you would see to ultimate drive its mechanical properties. And so with speed and dual cure, we were able to not just produce parts at scale effectively, but we were able to give properties that no one else had ever seen before in the additive space, which was truly getting thermoplastic properties out of a UV curable system at great speed. And that is what allowed us to get into the large-scale production or making things that people actually cared about. I think the misunderstanding in additive as a whole is everyone talks about the printers. Everyone is focused on the hardware itself. The hardware doesn't matter. If you can't make a material that actually performs to a standard set within a certain application space, you don't get to play in that application space. If I don't have a material that is FR rated, that is flame resistant, I just simply don't get to play in the world where flame resistant materials are needed, like transportation and aerospace. And so the material is actually the key piece and what allows you to even start playing in the application side of things. If I don't have a material that behaves well in the body, I don't get to play in medical. It's as simple as that. It doesn't really necessarily matter what the machine does if you don't have the materials. And I think that was a major focus for us. I mean, if you look at any of the other additive companies, nobody was spending the amount of money that we did on material innovation. And then the third piece of it was really around what I would say is education of how to use the technology and how to take advantage of it. And it's still the biggest issue. Now that the technology and the materials are there, it's truly around how does this fit next to my entire manufacturing solution? How do I think about this and it can better my product lines?
It's really well outlined there. And, focusing on this material science piece, I think that's a real cornerstone to how you view things differently. What are the types of materials that can be 3D printed?
So we at Carbon, we essentially only deal in the world of polymers. Now, our polymers range from highly rigid glass-filled like systems all the way to highly elastic, energy-returning, damping elastomers, and everywhere in between. That is sort of our pioneer. And I think the unique thing that, as I alluded to earlier, is we work from customers backwards on the type of materials that we work on to launch. And it's mainly built around a specific application that we believe is referenceable to a broader market and has a huge opportunity. But now in this world, you're seeing folks print in more and more metals, and particularly really high performance, elaborate metal systems, from cobalt chromes to high-end titanium systems. You're seeing folks print more and more, what I would say in the biologic space, which is becoming really interesting to watch and has a huge amount of opportunity, I think, in the long run. I think it's been fun to see how people have expanded the materials approach. There's folks printing in glass now, bioabsorbable systems. It's really taken off in that sense. And I think it's mainly driven on because the realization that's happened in the last 10 years of the 3D life that, again, the printers aren't what dictates the opportunity. The materials determine the TAM.
One of the things that you picked up on was this concept of mass personalization of products and sort of, opens up this new frontier around how we produce and how we consume. How does that future play out to you, and what are some examples you're seeing already?
I think mass customization is truly the large opportunity in the future. What we have seen is that it has been pioneered in the healthcare space for 3D printing and has been driven by markets like dental. I think dental is one of the sort of unsexy markets in the space, but if you think about it, it's a massive opportunity, and everything that is there is made custom N of one. Historically, that's been an artisanal craft. People hand-making crowns, people hand-making dentures, people hand-making all the appliances that go into your mouth, whether they be braces for orthodontics, using the traditional wire and bracket approach. The area that has seen the biggest sort of explosion and adoption of 3D printing has actually been the oral health space. It's been really interesting. People tell me, who's the furthest along in digital production? And everyone expects you to say like Boeing or aerospace or companies like Stryker. It's actually dental. Through that, because everything's N of one, because everything's digital, we've been able to, the industry has been able to parlay that technology into multiple different other areas. Hearing aids. Pretty much every hearing aid that you buy is custom printed. It was one of the first major things. Orthotics is starting to become the only way to do it is by printing. And those areas really pioneered for what you're going to see now, which is pretty much every major consumer product company that we're engaging with has some strategy to release a custom product at scale. It's been so fun to watch. I mean, we think about what Carbon does specifically, and I give examples of other companies, but if you watch any NFL or NHL game, majority of those helmets are produced by Carbon, are on Carbon machines. Each one of those are custom made to each one of those players, head scanned, and the technology, depending on sort of what position they play, really comes up with the best lattice approach for that player, that athlete. But I think the big thing that you're going to start seeing is it's no longer going to be just for these $200 million a year players. It's going to be for every high school player, college athlete, and junior athlete is going to be able to get access to the same technology at scale. Bike saddles. There is no other way to make a printed, or a saddle nowadays that can be custom for you. And you think about it, if you ride bikes at all, the saddle is probably the most important piece of an entire bike. You can buy a $20,000 bike, but if it's not comfortable, you're not going to ride it. And it's the most personal of the aspects for that bike. And every major bike company in the world is now doing 3D printed bike saddles because they know it's the way to make the most comfortable bike saddle. Now, starting this year, you will start to see them all offer not just a printed saddle, but a custom to you saddle. You will go in, you will sit down on a pressure map. And if you and I are both bike riders and I'm 200 pounds and you're 150 pounds, our saddles should be different. But today we both buy the same saddle, right? And I think that's the major differentiator. And you're going to see that continue to be prevalent across the entire consumer product space. And I think you're going to start to see it go more and more even into the world of automotive and what I would say is like higher medical spaces outside of oral health. When you think about hip replacements, that hip replacement shouldn't be size small, medium, large. It should be custom to me. And I think you're going to see the same thing happen in footwear too at scale. So these are all things that we as consumers are going to be massively benefiting from. We will no longer have a size 9 shoe. It's going to be a size Phil or a size Daniel. And that's what it's going to be about. And I think that is going to be a huge opportunity and one to really look out for, particularly over the course of the next 6 to 12 months.
So it seems that there are two critical components to what you're talking about here. One is the mass customization and production side via 3D printing. And then there's the other, the data input piece via image captures and sensors. What are the advancements on input capture that you're seeing?
So when you think about those two sides, which is the data capture and the production, there's actually also a piece in the middle, which is how do I design N of one designs to produce by the millions in real time without any human intervention.
Yeah.
Right? Because if I'm looking at this helmet has over 150,000 unique struts in it, designed specifically to that player. You could not manually manipulate that in order to make that scalable. So the thing is I think back in 2013, it was a pipe dream to do large scale customization. How do I digitally scan and collect data at scale? Again, you talk about the digital scanning capability, and it really was a tough thing. You had to use blue light scanners, which were expensive and wasn't something that grew on trees, right? Not many people had it. And as much as, we talk about Apple and Google, the major thing that they brought to forward is the capabilities of these camera systems on the back have gotten amazingly good. And that is truly what enabled the ability for this to scale massively. So when a player is getting their head scanned, it's an iPad app. They wear a funny looking sock on their head that has a bunch of dots on it. And you walk around and it gets within 0.5 millimeter accuracy of that digital scan, which is way more than good enough for what you need to go do to produce a helmet. Now, the next thing is again, as I stated, is I can collect that data, but how do I make design at scale? Every Lattice product that you see that we produce leverages our design package. It takes the scan file in. It knows how much space is between your head and that shell of that helmet, and knows the impacts that you're going to receive through the finite element analysis results that we receive from partners. And it determines what lattice should be where based on that information, and does a simulation in the cloud to make sure it's then actually fabricatable, that you can actually print it and adjust accordingly. And
wow.
Doing that was a super important piece, because what we're talking about for saddles, or what we're talking about giving this not just for Patrick Mahomes, but giving it for a high school athlete down the street, you had to be able to produce those digital files at scale without any human intervention. And that was the missing piece. So it was funny. I mean, I would state it as getting to the world of custom is really around a bunch of doors that have to be knocked down. So, again, we talk about the hardware and the materials. We had to knock down that door. We get through that door, and then we say, okay, the scanning is not prevalent. So what are we going to do? And luckily we had some, other macro themes happening that helped with that. So that door started getting knocked down. And then it became okay, we can get the scan, we can print an object. But if I have somebody manually designing this, it's going to take forever, and you're simply not going to be able to do it as good as a computer could do it. And so building that program to be able to do that effectively using cloud-based architecture allows us to go through finite element analysis design that historically on a normal laptop like you and I are on right now would take hours. We're doing it in single-digit seconds through leveraging GPUs in the cloud. And so all of those pieces have to come together in order for this to be done effectively. And I would state that it would have been the right idea 10 years ago. It was the wrong time. We didn't have all the pieces that we needed. Now's the right time, and you're going to start to see it happening massively.
Let's dwell on that software piece, because really you're talking about computer originated design and led design, which I think is a huge idea. And if that's already here today, what does that look like in a couple of years from now on this trajectory curve?
I think it's huge. I mean, when you look at what AI and ChatGPT has done, the thing that not many people are talking about is what it means in geometry. Go to any design school in the country, even the D school at Stanford, which is arguably one of the best in the world. The first sets of classes you take are, here are all the things you can't do. That's how the classes work, because you shouldn't be thinking about things that you can't bring into the physical world. So you're really about creating these boundary systems. Okay, so I know I can't have variable wall thicknesses. I know I can't have draft angles of certain ways. So I'm trying to get creative within my sandbox of what I can play in. That's absurd. That shouldn't be how it's done. Now, the reason why that's done is because you didn't have a technology that could handle complexity to bring it into the physical world. 3D printers, complexity is free. Yeah. It doesn't mean there aren't design rules, but complexity is free. And what I would argue is the more complex the product is, the better it is to 3D print. And so imagine prompting a system where it's like, I want a hydraulic system that has all of these inputs that maintain certain flows. It can run a simulation of way more types of geometries than you and I could ever think of. It would take us a lifetime, and we'd still not be able to do it as well. I think everything is going to improve. I think the AI of the physical world is going to be a way more interesting spot to be than it's going to be in the world of large language models.
What are we seeing in the medical space as we combine AI-led design with biological and organic printing materials?
Yeah, I think what you're starting to see actually happening is it's the printing of scaffolding of which cells can grow. And scaffolding is a material that is made of a material that cells like to live in. Is becoming really, really interesting. And I think you're going to see things from, we talked about from not just like body part production, whether it be, ears or limbs or things like that, but into the world of, just human tissue. You think about the world of plastic surgery and even in the world of breast augmentation, and you think about breast implants. Having something that's more designed and specific to you and growing your cells through them, I think is a direction that is going to be super interesting for the world to see, even to the point of creating those scaffolds of which, I think people are working on here, which is like creating, meat, a sort of a meat that is truly, made of, beef cells, but no animal had to die, is the stuff that folks are actually working on already. And so when I think about medical and I think about the printing of biologics, there's a lot of opportunity in that space for sure. I think the other aspect is the materials capability. You're going to start to see folks printing in the world of micro, which is a very interesting spot because you think about, the world of semiconductors. The whole goal there is to get smaller and smaller and smaller, and we can do nano world very well, right? We can also do the macro world, 1,000 microns and above, really well. There is a gap between nanometer and microns that the world of fabrication is really bad at. There's not a really good solution there. The printing technologies are going to actually help pioneer a whole new space of that. So whether that be through printed synthetic blood, because you actually can print blood cells, which is in that 6 to 7 micron range, which is a really tough fabricating range to be in, whether that be delivering, printing microneedles for delivery of vaccines. Think about a COVID-like world where we were all waiting for a vaccine and the cold storage required in order to handle it. Imagine just receiving a sticker in your mailbox of which you put on like a temporary tattoo, and that is your vaccine. No cold storage required, transdermal delivery at mass scale in real time. Like, we're not that far away from a world where that exists. And I think it's going to completely upend how we think about the world of healthcare in particular.
Fast forwarding a little bit into that reality, what types of businesses start to form and who gets disrupted, and what are kind of the new economics of that world?
I think it's the world of centralized production, particularly in Asia, is going to be hugely upended. That's going to be the first thing, I believe. Because, historically, that's the only place you would consider it, right? Because the supply chains are all built there. But in a world where you can make things anywhere, the startup of a factory, I can give you 4 machines, ship them to you tomorrow. You can be operating them tomorrow and producing tens of thousands of parts completely on your own, no matter where you are in the world, just simply with a normal, plug in the wall. That is a very unique power. And manufacturing had to be centralized because it physically had to. Creating a greenfield factory is a lot of money and a huge amount of risk. If you can do things where you've got essentially 10 printers in a shipping container, I can produce the world's needed volume of hearing aids within that facility in a year.
Wow.
It doesn't take a whole lot. You're producing, roughly like 3 to 4 million hearing devices per printer per year. I mean, it's I think a truly incredible moment. So I think that's going to happen first. And I think it's interesting because you think about all the benefits, and maybe benefits that aren't even top of mind for people. We talk about, today about import and export taxes, right, on products. If you're shipping a digital file to produce, those go away. And that has a pretty significant impact for places that truly rely on that revenue stream to function. And you think about the trade wars. Trade wars become really interesting if everyone can produce on their own and everyone has a capability of doing it on their own. So when I think about like geopolitically, I think 3D printing has an interesting set of problems ahead. And it's not problems with the technology itself, but it's problems with how people manage it and what it means for how things are produced. I hate the idea of the environmental impact of shipping things. It's unbelievable. Like, if we produce an orthotic or a set of helmets, why does it have to be produced in Asia and shipped? You kind of defeat the whole purpose. I want to produce in geo-region. And oh, by the way, it opens up designs because, I think when I think about consumer product companies, and you go to companies like Adidas, the designs that sell in Europe don't sell well in Asia. And the designs that sell well in Asia don't sell well in the United States. Everyone's got their own preferences, and cultures have their own preferences. And the ability of making things in location based on the preferences of the culture and people, I think are really, really intriguing to think about. I think anybody that's not adopting custom is going to be left behind. I think the more and more things are going to be custom because it truly is a better product. The aspect of making things at scale and of one is truly going to be where things are going, regardless of whether 3D printing is involved. But I think 3D printing is going to pioneer the benefit of which others are going to have to start innovating in their segments for what their answer is to it. Because at some point, you and I as consumers are going to expect it. Like when I get my AirPods, I'm going to expect that the AirPod is for me, not just a mass-made thing that falls out of my left ear and falls out of my right ear randomly. I want it to be made for me. And we all deserve that. And I think that's where the future is going to go.
So many big ideas that you just unraveled there. And, one is the idea of this onshoring of the manufacturing capability. So does that mean that we're just seeing a flow of materials between different types of nation states and a flow of IP and digital files requesting for things to be created? And if that's the case, like, are we set up as a world for that reality?
No. I mean, can you imagine if the amount of trade revenue on export from China declined by 30%, what would happen? It would have global impact. And so I don't think we are prepared for something like that happening. And I know that's an extreme case and it won't happen overnight, but it creates what I would say is like a moment that, the world is not prepared for. The identities of nations, of what they're known as, will need or have to adopt and change. And if they don't, I think it just creates geopolitical uncertainty accelerated. In my mind, it's like, how do you police digital file, flowing around? How do you tax that? How do you know it's even happening? I can easily imagine a place where, and I think about like spare parts as being a good example of this, which is it totally makes sense for companies like John Deere and Kohler to digitize their spare part inventory and allow people to make it at scale. I think like 30% of the revenue, though, is spare part inventory, spare part revenue. So how do they control it? It becomes a really interesting problem. You can go to Moline, Illinois, and they have one of the largest cement reinforced warehouses in the country. And I've been there. You can drive around in it for miles. And that's where John Deere keeps their inventory for spare parts. Because when a combine goes out, it's expected to work for 20 years. And if that combine goes down, it costs them money for every hour. So they keep everything. It's over $2 billion worth of spare part inventory that's just sitting in the warehouse. And you would easily imagine a place where they allow you to buy a file, almost like buying a song from iTunes, being able to print it once. But how do you control it afterwards, right? And it becomes a really interesting thing. I don't think we are prepared for what it means. I also don't think it's an instant moment. It will happen sort of like boiling a frog kind of thing. But when it does happen, I do think it could create destabilization in the world order of what we know today, whether that be geopolitically or whether that be in some of these companies that we think are iconic for what it's for them. There was a 3D printing company recently, and I won't say who they are, but they released a pretty high profile product. They sold out in hours, and within 24 hours, the digital file for the product that they had launched was already on the internet for anybody to buy and print. It's a really interesting issue.
And so if you had to project out, let's say you're an individual, you come up with a novel product idea sitting at your house and you decide to create a digital file, release it out there, catches on globally like wildfire. Is that the type of businesses and entrepreneurial opportunities we can start to see if we can protect that IP and sort of have some sort of revenue stream back?
I think so. I mean, I think, and if we create an iTunes for digital files that people actually want and allow for the musician, if you will, but the engineer that came up with the product to be able to make money off of it and get royalties based on it, then I think it could be a really interesting way to do this. I mean, it's not like the problem I'm suggesting has not been solved before. It just means I think it's pretty far behind. And there are folks that are doing this today.
I'm just imagining a world that's incredibly unique in terms of what people are wearing, buying, producing, and just a far richer, more diverse world to live in from there. So thanks for painting that picture for us and for all the work that you're doing at Carbon to make it reality. It's an incredibly disruptive sort of chain of thought to go on, and a really exciting one. So thanks for coming on to chat to us, Phil.
Awesome, Daniel. Appreciate it. Thank you for having me.
I could have chatted to Phil for hours, as the changes that 3D printing may bring to our world once at scale will have such deep and profound impacts. So many topics ranging from healthcare to food to mass customization, the disruption of global supply chains, and how IP will be reinvented stand out. One that resonates to me as a software investor is the notion of computer-led design combined with the manufacturing capability that, as Phil puts it, complexity comes free. The potential for new and superior goods as a result are endless. This is one future that I'm truly excited to see materialize. To follow Phil and the work being done at Carbon, head over to his Twitter account at PhDeSimone. That's PhDeSimone. I hope you enjoyed today's episode, and please subscribe to the podcast to listen to more episodes coming down the pipe. Until next time, thanks for listening and have a great rest of your day.